What's up, math fans? Welcome to Proofs. I want to prove that triangles are congruent, and there's a lot of ways to do it. So today I'm only going to talk about SSS, which stands for something. I'll show you in a minute. Take a look at this problem. I got triangle ABC and I got triangle NOY. That's no coincidence. My question is triangle ABC this symbol to NOY? And hopefully somewhere in your experience you've seen this symbol before. The symbol, I'm going to break it up, is a squiggly on top and also an equal sign underneath. So what's the squiggly? Similar. What's the equal sign? Equal. For a shape, when I put that together, make that sandwich, the symbol is congruent. So I need to be able to prove triangles are congruent. This is the symbol for congruent. You need to understand that when a shape is congruent, or when two shapes are congruent, that means they're both equal and similar. What does that mean? Well, equal means the sides. The sides have to be equal. The corresponding sides have to be equal. 3 is equal to 3, 5 is equal to 5, 4 is equal to 4. So easy, I already showed you that they're equal. You're welcome. But are the shapes similar? Hopefully you saw a video on similar shapes, specifically similar triangles. So what did we say about similarity? Let me give you a throwback example. Here's a triangle. Here's a triangle. Let's say I do this. Is this similar to this? If this angle is corresponding and congruent to this angle is corresponding and congruent to this angle, you don't know anything about this one. You don't know anything about this one. Are they similar? The answer was yes, because these three have to add up to 180. These three have to add up to 180. So if these are already the same as these two, the third one has to be the same. So they are definitely similar. And that was called angle-angle postulate of similarity. As long as two angles are congruent to two angles of another triangle, then the shapes are similar. Because you're assuming that the third angle is also congruent. So it's really, originally, all three angles have to be the same. If all three angles are the same and you don't know anything about the sides, you can say they're similar. But then we discussed that you don't need the third angle because we already know the third angle is going to be congruent to each other. So then we said, oh, the shortcut is just angle is enough. I don't even have to mention it because I already know. So angle is enough. It's called a shortcut for similarity. All right? But, or using that for congruent, which is this shape, means I need to know similar, means I need to know angle, and I need to know equal, which is all the sides, right? All the sides. How many sides are there? 1 pair of corresponding sides, 2 pair of corresponding sides, 3 pairs of corresponding sides. So I need to know side, and I need to know angle, and technically you should know or assume that the third angle also, right? So this is the long way. To prove congruence, you need to prove equal and similar at the same time, which means you need to prove angle, and side, all at the same time. You need to prove 6 things. That's a lot. Mathematicians are lazy. We look for shortcuts. For a shortcut, I already said, you don't need all 3 angles. You just need 2, and you can conclude the third one without saying it. Side. So now I need only 5 things. Can I make it even shorter than that? Well, look at these triangles. Did I give you any information about the angles? Do I need to even show you the 2 angles? No. When you have side, for these 3, 4, 5 to stick together, and this 3, 4, 5 to stick together, it can only be one type of triangle. You can't bend it any other way, because if I take this and bend it this way, it forces that third side to get longer. There's no way I can make the same 3 sides without changing the angles, or with changing the angles. It's impossible. The angles are locked. So you can assume angle. You don't even need to say it. The minimum amount of information is yes, because the 3 corresponding sides are equivalent. That's it. The short, lazy way is to say side. You don't even need angle, angle, angle. As long as you have side, 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 you know the angles are locked, you're good. So that explains how to prove it using side, 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 all right? So yes, these two triangles are absolutely congruent. So now I know for sure this angle is definitely congruent to that angle. This angle is definitely congruent to that, and the third one, and the third one. Simple. I made it harder than it had to because I wanted you to understand the idea behind it. Once you understand it, you can skip that other information. Okay? I'm gonna get over here now. So here's how it applies. They give you a shape, no numbers. What do I do? Well, they're asking you, is triangle MNO, look at MNO. Can't see it, you having trouble? Get a different color, or a highlighter, or darken it in, or a pencil, or whatever works for you. So MNO is this triangle on the side. I'm gonna draw it, and I'm gonna say, okay, so M is up here, NO. Hopefully that looks like a triangle to you. I got a little sloppy. And MNP, oh, and this is a bad, should be a triangle here also, MNP. So MNP is this one. And I did this with dilations also. If you were watching my dilation video, separate the triangles. It really helps to see it. MNP, N is here, P is here. Okay? I want to prove that they are congruent, and you already know the clue is I'm looking for side, side, side. I don't know anything about the angles. Can I use side, side, side? Here's how you set up a proof. A proof is an explanation, step by step. Explain, explain, explain. Say something and explain it. So I'm gonna say something, that's called my statement, and then I will explain it, and I'll call that my reason. This is considered a formal proof. Most people don't really like it. It's not a very popular chapter, proofs, but you got me, so you will like it. All right, what could I say? Can I say anything? These dashes gotta be telling me something, right? So instead of numbers like my last one, dashes mean the same thing. You're telling me that NO is the same as NP. That's what the dashes mean. So that's my first statement. NO, side NO is congruent to side NP. How do I know that? Because you put dashes there already. Also known as given. It's given to you in the question. Very simple. First statement is generally given. Let's see if there's anything else that's given. Look, look, look. Ooh, more dashes. Double dash, double dash. So what is that telling me? Say it. M-O, excuse me, M-O, mo, is congruent to MP. How could you say that? Because there are dashes there, because there are dashes there. Or, more simply, because it's given in the question. You show me, I say it because you said so. That's it. This was given in the question. I'm just spelling it out for you. Say what you see. Say what you see. Do I see anything else? No. So how could I prove that this is congruent to this if I don't know the third side? You just told me I need all three sides to be congruent, and I don't know the third side. But look at the picture. Look at the picture. What's the third side? Can you name the third side here? Can you name the third side here? See the picture? MN is the third side in the green. MN is the third side in the brown. MN was shared by both triangles. MN is the same as itself. I just kind of ripped it apart, but it's exactly the same line. So MN is congruent to MN. And it's so easy and so obvious that people don't even see it. MN is congruent to itself. Duh. You are your own height. Duh. So, is it given? You could argue that it's given, but the better answer is reflexive. When you say something is congruent to itself, it's reflexive. It's like looking in a mirror. MN is looking in a mirror and it sees, ooh, MN again, we are the same height. If it's not a funhouse mirror, that's when they mess with your heights. Right? Reflexive property. So what do you want me to prove? This thing, I got a side, another side, congruent to the corresponding three sides. I'm done. Conclusion, dot, dot, dot. 3 dots here means conclusion in a triangle form. Triangle, MNO, is congruent to triangle MNP. Why? How could you, that's a 4. How could you possibly say that? Well, because I just showed you side, 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 side. And that is a formal proof showing congruent triangles. The question is side, side, side the only way to do it? Is side, side, side the shortest way to do it? Stay tuned. Thanks for watching. See ya.